Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, students. So the reason for this review session is to help you revise for this science quiz on Sunday, inshallah. Should be easy, inshallah. So please just pay attention with me, and hopefully by the end of today, you will be able to answer a lot of these questions, and you'll feel a lot more confident with this test on Sunday, bi'idhnillah. Okay, so the test on Sunday, the quiz on Sunday is going to cover units 1.1, 1.2, and 1.3. So these units are motion, velocity, and acceleration. Okay, and if you need to go back through those videos covering 1.1, 1.2, and 1.3, please feel free to go back through those videos. They're available on the channel. Otherwise, this is a revision quiz video. Okay, so the first question here asks us about motion. What is the SI unit for distance? Now, first of all, in order to be able to answer this, we need to understand what SI stands for. So SI stands for Standard International, which is basically just the international standard of units. So what we mean by international standards is the units that are used by all countries. All people will understand it. So if I go over to the UK, if I go over to New Zealand, if I go over to Australia, if I go over to the United States, and I say I have covered a distance of so and so meters, they will understand what I'm talking about. However, if I say my height is 12 bananas, they will not know what I'm talking about. So what we mean is standard, something uniform, something that everybody will understand. Turns out for distance, the standard unit is meters. Okay, now I don't want you to be confused. People do use foot, people do use mile, people do use kilometers, and these are all valid units. Okay, but the standard one is meters, and kilometers is really the same as meters. Kilo, the word kilo just means 1,000. Okay, but the correct answer here, the standard unit is meters. A change in position with respect to reference point is known as what? Well, what do we mean by change in position with respect to a reference point? Once again, we need to understand the question. So remember what I said in science, when we're talking about movement, we're talking about change in position. So I'm sitting down here and I'm wiggling away. That's not really changing my position. My change in position, when we're talking about change in position, we're talking about changing places. So I'm moving from one place to another. But how do I count? How do I say if I'm moving or not? It has to be in relation to a reference point. It has to be in relation to a fixed point, a point that's not moving. So if I look at the background, for example, look at the background, look at this cupboard behind me. Am I moving? Yes, I'm moving with respect to the background. So as long as it's with respect to a fixed point, because the background isn't moving, that's a fixed point. Fixed means not moving. So a change in position with respect to a reference point is motion. So that is what we refer to as motion. All right, very good. I think the answers are here actually. Here we go, motion. So the answers are here, so I don't need to write over them. Suppose you are on a train, list some objects that make good reference points to determine whether or not the train is moving. So once again, um, basically anything that's not moving is going to make a good reference point. So if the train is moving, so here's the train. Here's my very, very badly drawn train. Okay. And well, there we go. So that's the train. That's the front. Those are the windows. And I want to know if the train is moving. I'm sitting on the train. I want to know if it's moving. The easiest way to tell is by looking outside the window. And then I can see, for example, a tree. So the tree's not going to move, is it? It's a fixed point. What about the station itself? The station itself is another good point. So the station could be stationary, obviously. What about a bird? Now, a bird is not going to make a good reference point, are they? Because a bird is moving, we want a fixed point, something that's not moving. So not really a bird, not a cloud either. Cloud is going to make another bad point. So not a bird, not a cloud, something fixed. Maybe a traffic light, maybe a set of traffic lights over here. That would make a good reference point as well. Okay, so any answer to that one? A flag. Yeah, a flag is a good one. Okay, so anything that's fixed, that's not going to move. Let's go next. Here is an illustration that describes a situation here. We've got a plane, we've got a car. It says compare and contrast. Suppose you are standing on the sidewalk. Describe the direction of your motion relative to the car and the plane. Okay, so if the car is moving that way, and if the plane is moving that way, then relative to them, I'm actually moving that way. So that is what that means. So basically, because they're moving past me, it looks like I'm moving forward. It's all relative. That relative just means it depends on other objects. So let's say, for example, you're in a car and you're moving, and there's another car that's moving as well in the same position as you, and they're moving at the same speed. Then relative to each other, you're not moving. The same situation happens if you're on a plane. If you're on a plane, you're sitting down, the plane is moving, you're moving, the person next to you is moving, everyone on the plane is moving. However, if you look over the person next to you, it doesn't look like they're moving. And to them, it doesn't look like you're moving. But of course, both of you are moving at 1,000 kilometers per hour. It's just that relative to each other, as long as you're moving together in the same direction, it doesn't look like you're moving. So that's what we have here, basically. The person looks like they're moving to the right. Let's look at the next example. Oops. Okay, so the next example over here, what quantity, just a second, sorry. No, we're good. Okay, so what quantity can you calculate if you know that a car travels 30 kilometers in 20 minutes? If you know that a car travels 30 kilometers in 20 minutes, what quantity can you calculate? Well, based on that, I know the total distance covered by the car. So here's a car. It has moved a distance of 30 kilometers in 20 minutes. That's what it's saying. So it's moving at 30 kilometers. Okay, it has moved 30 kilometers and it took 20 minutes. So that means, well, let's see, we've got the distance, we've got the time. Remember, speed equals distance over time. Do we have the speed? We don't have the speed. But I can calculate the speed. Oh, I can calculate the average speed. Indeed, I can. And it's the average speed because it's the speed for the whole journey. I don't know if I slowed down and I sped up and I stopped at a traffic light, I went to the Bacala. I don't know any of those things. What I know is I know the total distance and the total time, so I can work out the average speed. And the average speed in this case, if you're interested, it's 30 kilometers in 20 minutes. So what that means is I travel about 1.5 kilometers per minute. Okay, or in an hour, 20 minutes, so that means I've got 3 of those in an hour, so it's going to be 90 kilometers in an hour. Okay, on the graph of distance versus time, the slope of the line indicates the what of the object. Okay, so that's another interesting question. So on a distance versus time graph, distance versus time graph, let's have a look. So a distance versus time graph looks like that. Distance is on this side, time is on this side. What does the slope represent? Well, distance over time. Literally, it represents speed. Remember, speed is distance over time. The unit for distance is meters. The unit for time is seconds. And that is, in fact, the unit for speed, which is meters per second. One more point I'd like to say here is that obviously the slope of the line is directly related to the speed. So over here, this here, A, B, and C, which one of them is going to be the steepest? A is the steepest, and therefore A is the fastest. And if you, another way of remembering this for those students that kind of struggle with this is you can put a ball on top. Which one is going to slide down faster? Which one's going to slide down faster? The fastest one is going to be A. It's nearly dropping off. And then D is going to be the slowest. So the steepness of the line, the slope, represents speed, and the steeper it is, the faster the object is traveling. Okay? Let's move on. So that represents speed. Moving on. So here we've got a graph, and it says the graph shows the motion of a remote control car. Use the graph to answer questions 8 to 9. During which time period was the car traveling the fastest? So we're just talking about that. So basically, remember, if the line is steep, then it's going very fast. If the line is like that, it's not very steep, then it's not going very fast. There's that slow and that's fast. Of course, that is in a distance versus time graph. Okay, so let's have a look here. This is distance time. Look at this. That's the slope. The slope over here looks like this, and the slope over here looks like this. So it's quite obvious from the slope alone that this part of the graph here is the fastest, and that is 0 to 4 seconds, 0 to 4 seconds. Okay, what about the next one? What was the speed of the car during the first 4 seconds? So now they want us to work out the speed. Well, we already know that speed equals distance over time, and so speed is equal to distance. What's the total distance? 4 minus 0, which is 4, and the time is 4 minus 0, which is 4 as well. So it's 4 over 4, also known as 1 meter per second. That's the answer there. Okay, that's how you work that one out. So that's number 9. Number 10. A family takes a trip. They travel for an hour at 80 kilometers and then 2 hours at 40 kilometers per hour. Find the average speed during the trip. So what that means, remember the speed, the average speed is going to be distance covered over time. So we can work out the distance covered. So we know that they traveled for 1 hour at 80 kilometers. So that means 1 hour at 80 kilometers. That means they've covered 80 kilometers because they traveled for 1 hour. So if they're traveling at 80 kilometers every hour and they traveled for 1 hour, that means they've covered 80 kilometers. So the first hour they've covered 30 kilometers. That's what they've covered in the first hour, 80 kilometers, sorry. And the next 2 hours, second hour and third hour, they traveled 40 kilometers in each one of those, and then 40 kilometers as well. So what does that tell me? The total distance D is 160 kilometers. And the total time was how many hours? 3 hours. So the average speed is going to be the total distance over the time. So it's going to be 53.3 kilometers per hour. That's the answer. Okay, easy, wasn't it? So that's all you have to do. Remember, just remember this guy here, that speed equals distance over time, and you'll be fine. Okay, so that's 1 meter per second there, and this one here is going to be 53.3 kilometers per hour. Okay, acceleration. Now, acceleration, remember, is change in. Acceleration is, excuse me, just a second. Yeah, here we go. Acceleration is change in speed, s2 minus s1 over time, or just speed over time. Or really, if you want to be more accurate, it's change in velocity over time, because remember, acceleration is about change in either direction or speed. That's what acceleration is. So let's have a look. The rate at which velocity changes is acceleration, obviously. The rate at which velocity changes is acceleration. And let's have a look. Oh, so it is acceleration. And of course, you can calculate the acceleration of an object moving in a straight line by dividing the speed by the time. That's the formula for acceleration. You're going to have two formulas. Speed equals distance over time, but then change in speed over time is acceleration. So acceleration is change in speed over time. Okay, let's have a look. So this time we've got a different kind of graph. Always make sure that you understand what the graph is saying. In this case, it's speed time. So the slope of the graph, remember the slope of the graph is going to represent acceleration. In a distance time graph, distance time, the slope represents speed. But in a speed time, the slope represents acceleration. Okay? Just remember that, please. Okay, what is the skier's acceleration? How do we calculate the skier's acceleration? Well, it's easy. We know the formula. Acceleration equals speed over time. What is the speed? What is the speed? Well, I can pick any speed I want to and any time I want to from the graph. But I'm going to pick 16 and 4. I can do that. So let's have a look. So that's 16. So what's the time? That's 4 seconds. And 4, the time is 1 second. So now that we have the information, we've got the final speed. Remember, the formula is such: final speed minus initial speed over the time, the difference in time. So T2 minus T1 just means the final time minus the initial time. So what's the final speed? Here it is, 16. That was the final speed. What's the initial speed? Here it is, 4. And what's the time? Final time is 4, easy, 4 seconds. And the initial time this time is 1 second, because I chose it. I chose to not go to 0. So what that means is going to be 12 over 3, which is 4 meters per second. Squared. Don't forget the squared, because we're talking about acceleration. Okay? And that's the answer. Okay? That's the answer there. And you'll get the same answer if you go 16 minus 0 divided by 4. If you go 16, instead of going to 1 second, you go to 0 here, it's going to be 16 over 4, which is also 4. Or if you decide to go 12 divided by 3, or 8 divided by 2, or 4 divided by 1, any of those is going to give you the same answer. Right, let's go to question 14. A ball is dropped from a window and takes 2 seconds to reach the ground. It starts from rest and reaches a final speed of 20 meters per second. What is the ball's acceleration? Okay. So the first speed, S1, equals 0 meters per second, while S2 all the way down here is going to be 20 meters per second. And so, how long does that take to get down here? Remember, it took 2 seconds. So we can work out the acceleration, because the acceleration is going to be the difference in speed over time. So acceleration is equal to S2, which is 20, minus S1, which is 0, divided by the time, which is 2 seconds. So 20 divided by 2, it's 10 meters per second squared. Easy. Okay, let's go to the next one. Yep, that's just confirmation. Okay, so here's another graph, and this is a distance time graph. So it's a describe the motion of the runner in as much detail as you can. Which runner won the race? How do you know? Suppose the graph showed the runner's motion until they come to a stop. They came to a stop. Describe how the graph would change. Okay, so we've got 2 runners here. We've got Jen and Anne, and they're both racing. Obviously, the distance is the same because they're both reaching 50, aren't they? They're both reaching 50. So obviously they're doing a race. So let's say here's Jen, here's Anne, and it's a straight line, and this is the finish line, and it's 50 meters away. It's 50 meters away, and I know that because they both get to 50. But one of them's taken 6 seconds, and the other one's taken 8 seconds. So Jen's taking 6 seconds to get to 50. I'm going to write that in the end. I'm going to write down the finish line. And while Anne has taken 8 seconds to get to 50. And so now we can talk about it. We can say quite a bit actually. We can say that Jen was definitely faster than Anne. She took less time, and I can tell from the gradient, from the slope of the graph, that she's faster. I can actually work out her speed. So 50 divided by 6, which is approximately 8.3. 50 divided by 6 is 8. Nope. Yep. 50 divided by 6 is 8.3 recurring. So that's her speed. 0.3 meters per second recurring. While 50 divided by 8 is a bit easier to work out. That is 6.25 meters per second. So she's obviously slower, and we can see that because her slope is not as steep, whereas Jen's slope is much steeper. Okay, so Jen was faster, the slope is steeper, the total distance was 50 meters. Yeah. Okay, The graph below shows the motion of a runner. What could the runner do to make the slope of the line rise? Okay, so this is the motion. They want to know what they can do to make it move up here. Well, we already know, don't we? Go a bit faster. So by increasing the speed, the person can travel the same distance in less time. And so they can still go to 800, but they'll cover it in less time by increasing the speed. Okay, so that's what that is. Moving on. Members of the Fairview Track Running Club are running a 5 kilometer race. What is the distance of the race in meters? 5 kilometers. Okay, so remember the word kilo. Kilogram means 1,000 grams. Kilobytes means 1,000 bytes. Kiloliters means 1,000 liters. Kilometers means 1,000 meters. The word kilo just means 1,000. I can say, for example, 1 dinar has 1,000 fils, or 1 dinar has kilo fils. That's all it means. It means 1,000. So 5 kilometers just means 5,000 meters. Okay, so that's D. Yep. What condition is necessary for an object to make a good reference point? Remember, a reference point is a point that doesn't move. So it has to be fixed, an object that is fixed relative to the motion you are trying to describe. Absolutely essential that the object is not moving to make a good reference point. Two objects traveling at the same speed have different velocities. Okay, so what is velocity? Velocity is speed and direction. Speed and direction. So if the two objects have different velocities and have the same speeds, well, we know the answer. That means they are traveling at the same speed, but they are traveling in different directions. So start at the same, nope, nope, nope. They move in different directions. That's the one. Okay, your family is driving to the beach. You travel 200 kilometers in the first 2 hours. During the next hour, you stop for lunch and only travel 25 kilometers. What is your average speed? So remember, when we're talking about average speed, you're talking about speed across the whole journey. The whole journey. So what was the time for the journey? It was 2 hours. Okay. So we've got 3 hours. 1, 2, 3 hours. During the first hour, I traveled, well, during the first 2 hours, both of these together, I traveled 200 kilometers. Whilst the last hour, I only traveled 25 kilometers. So the total is going to be 225 kilometers, yeah? 225 kilometers. That's the distance. That's the total distance. What about the time? The time is 3 hours. So that's the distance, that's the time. So the speed is going to be distance over time, which is 75 kilometers per hour. Okay, 75 kilometers per hour. Good. Use the graph to answer question 6. Write your answer on a separate sheet of paper. Well, I'm just going to have to write it here, sorry. The graph above shows the motion of a person. Describe the motion. Nice. Let me describe the motion for you. So first of all, this is distance time, which means the slope is what? Distance over time. That means the slope represents speed. Okay. They are moving at, and the other thing as well is you can see from the graph that it's moving in a straight line. That means it's moving at constant speed. That's for a distance time. If it was like that, then it means speeding up, because we're covering more distance in less time. And if it's like this, then that means we're slowing down because we're covering less distance in more time. So over here, it's moving at constant speed. So the way I would describe this is as follows. The person is moving at constant speed of 1.5 meters per second. How did you know it was 1.5? Well, it's 15 divided by 10, isn't it? 15 divided by 10. 15 meters divided by 10 seconds, it's 1.5 meters per second. So the person is moving at constant speed, 1.5 meters per second for the first 10 seconds, and then they stop. And then they stop. So from 10 to 20, they just stop. Maybe they went to the Bacala and they traveled at constant speed and then they just stopped. Or maybe they are going to say hello to a friend, and as they are walking, they got to the friend and they just stopped. Many reasons. There's literally infinite scenarios. So for the first 10 seconds, the person is traveling at a constant speed of 1.5 meters per second. Between 10 and 20 seconds, the person is not moving. Yeah, they're not moving. They just stopped. And that's that. I just want to say it's imperative that you understand. Let's just do a quick revision. That you understand the difference between speed and velocity. Velocity is speed and direction together. Velocity is a vector. Speed is not. But you don't have to worry about that. You just have to know that velocity has speed and direction. You must know that speed is equal to distance over time, distance covered over time taken, at least average speed is. You must know that acceleration is equivalent to the change in speed or change in velocity over time. Okay, and that acceleration can happen by changing the speed or changing the direction. Okay, and that the slope of a graph represents the slope of a distance time graph represents speed, while the slope of a speed time graph represents acceleration. Okay, thank you very much. Have a good day.